Please welcome Mandy Whaley.
Hello, universe. I am so excited to be here. My name is Mandy Whaley, and I lead our Azure DevTools team. And our goal is to help your job be easier as a developer. We build tools and libraries to help any developer working in any language be successful on Azure. One of the things that our team has been working really hard on is helping developers build intelligent applications that use the capabilities of Azure OpenAI. We've been working on SDK libraries, reference applications, tools, all kinds of things to help you build your own intelligent applications. And I'm really excited to share some of these with you today. Today, we're going to be looking at how you can build your own ChatGPT-like experience that's over your own data. We'll be using the Retrieval Augmented Generation pattern, or RAG pattern. This is a really popular pattern that's being used to add chat experiences across all different kinds of use cases and all different kinds of industries, across retail, healthcare, enterprises, any place that you want to help your team or anyone get to information effectively and quickly. For our example today, we're going to be building an application that helps a developer ramp up on a new technology. Playwright is an open-source framework for reliable end-to-end testing for modern web applications. Playwright supports multiple languages, including JavaScript and Python. It's super fast and has great VS Code tooling to help you get started really easily. For today's application, we're going to be using the playwright.dev Python docs as the data that we're going to have our chat experience interact with. We're going to build an application like this, where you can ask questions about the Python docs, get information back about how to use Playwright, get pointers to relevant docs, and even code snippets that you can use. We're going to go through everything that you need to develop this kind of application, to build and deploy it to Azure, and even to manage and test it. All of the resources are available on GitHub, and we're going to be sharing links along the way. So we're really excited to get started with this. First, we're going to take a look at the application architecture. So I would like to welcome to the stage Pamela Fox, one of our Python developer advocates, who's going to be taking us through the application architecture and diving into some key pieces of the code.
Hey everyone, so let's take another look at that app that Mandy showed. So after we ask a question, we see the response streaming in from the server a few tokens at a time. We also see citations show up inline with clickable links on the bottom. And clicking a citation opens the documentation page to the side in case we need a little more details. Then, if we want, we could keep the conversation going with another question, and the app is going to send this new question plus the conversation history to ChatGPT. So let's see what it says. In this case, ChatGPT decides to respond with a helpful Python code snippet that demonstrates how to write a basic end-to-end test using Playwright. And that test looks a lot like the actual end-to-end test for this app, actually, the ones that run on our CI. So how do we get ChatGPT to answer questions about our own data? So for this slide here, I have an example from sample data from an HR situation, and that's a really popular use case, is making these chatbots to ask HR questions, because it's a lot easier than looking through PDFs. So we use this approach called Retrieval Augmented Generation, or RAG, which basically means we provide context to ChatGPT when we ask a question. Our app implements a few different RAG approaches. I'm going to start with the simpler approach here. So we first ask the user, we first have the user question, and we take that user question and we use it to do a search on Azure Cognitive Search. So we send that to Cognitive Search, and that index contains the document in ChatGPT-sized chunks. So we don't have the whole document at once. We size them up so that they're appropriate for ChatGPT. And when we're using Azure Cognitive Search, we typically do a hybrid search, which means we both do text matching and we do vector matching, and then those search results get combined, and that's going to give us the best results, is both text and vector. Then we're going to pass, after we get back those results, we're going to pass the original questions plus those search result chunks to ChatGPT using a system message that instructs it to only answer from the provided sources. ChatGPT then replies with an answer that includes these citations, or it replies that they don't know if they can't find the answer in the sources. Cool, so that's RAG. What does RAG look like in code? And this is the code that I work on every day, so let's check it out. The front end is built in TypeScript with React components. When the user submits a question, the front end combines that question with their previous messages, as well as any additional settings. So we let them play around with stuff like whether to suggest follow-up questions, whether you're going to use a hybrid search, vector search. So we give lots of settings that you can experiment with as a developer to figure out what's getting the best responses for your domain. So we send the message, those questions, also authentication tokens if you're using authentication, if you're using ACLs on the data. We're going to send all of that stuff together and bundle them up and send them in an HTTP post request to the backend. So send that post to the backend, doing just a fetch request. So let's take a look at the backend code. The backend code is written in Python, which is my favorite language. And it uses the Quart framework, which is like Flask, but it's asynchronous, which is super important when you're making a ChatGPT app. So this app receives a request from the front end, and it sends it to one of our RAG approaches. So the approach we're going to look at here is chat, read, retrieve. It uses both the Search SDK and the OpenAI SDK. So first we can look at the system message. This is the message that keeps ChatGPT tied to the sources. Very careful to keep it in line, because you know ChatGPT likes to be very creative. But here we want to make sure it's tied to the sources. Now we can dig into the run method. So we go into here. This line here calculates vectors for the user's questions using the OpenAI embedding SDK and the Ada model. Then we take both the vector embedding and the original text query. We send those to Azure Cognitive Search. We ask it to do a search. We can specify language if we want to use this in different languages, not just English. You know, ChatGPT works in many languages. And then when the results come back, we can concatenate all the results together, all those chunks, in a format that's easy for ChatGPT to understand. So once we do that, we also need to figure out which messages we can include from the conversation history. And we have to make sure not to go over the context limit for the model. Every model has a limit of how many tokens you can send to it. And so if it's a very long conversation, we do have to limit ourselves. So we send that to ChatGPT, send the original user question, the sources, the conversation history, as much as we could do, send that to ChatGPT, and then we get back the response. We either return the JSON, or if we're in streaming mode, we return a JSON lines response with transfer encoding chunked. Anyway, those are the details. I'm happy to go into those in the booth if you want to come talk to us. We'll be there all today and tomorrow. And yeah, let's talk about the architecture of this. So, of course, being Microsoft, we deploy this to Azure. We deploy to Azure App Service. We could also use container apps or Kubernetes service, but App Service is a pretty good fit. The App Service uses a managed identity to interact with Azure Search, Azure OpenAI, and Azure Blob Storage, meaning that there are no keys in the repo. I don't like having keys in my repo. It freaks me out. There are no keys. We don't have to worry about accidental key exposure. It's all managed identity. For ingesting the data into the search index, we're currently using a script that runs over a folder. It uploads PDF files to blob storage. It uses Azure Document Intelligence to extract data from the PDFs and chunk them up into those appropriately sized chunks. It computes the embedding vectors for the chunks, and it stores both the text and the vector chunks into the search index. We could also run this job on Azure Functions or container app jobs or somewhere like that if we want to do a hosted ingestion. We have lots of different samples depending on what it is you need. Once again, come talk to me at the booth so I can try and hook you up with whatever you need for your use case. So now that you've seen some of the code and the architecture, I'm going to hand it off to my colleague Savannah from the Azure Developer CLI team, and she's going to talk about how we set up that architecture with a single command.
All right, so let's talk about how we can get this application up and running on Azure quickly using the Azure Developer CLI. If you're unfamiliar, the Azure Developer CLI, or AZD, is an open source tool that provides higher level, developer-friendly commands that help you build, deploy, and manage your application on Azure. AZD commands map to key stages in your developer workflow so that you can focus on writing application code instead of focusing on atomic operations on cloud resources. These commands were designed to feel familiar and map to a Git-centric workflow. So you'll see commands like azd init, AZD up, and AZD pipeline config, instead of commands that interact with specific resources and require you to pass in a bunch of hard-to-remember arguments. A typical AZD workflow might look something like this. Start out with AZD init to initialize your application for the cloud, run AZD up to package the application, provision infrastructure, and deploy your code, run AZD monitor to jump directly to your dashboards for application monitoring, use AZD pipeline config to set up a GitHub action with all the right repo secrets and variables for GitHub and Azure to communicate securely, codifying your deployment pipeline. But we're developers, so naturally you might be thinking, well, that seems magical or maybe too good to be true. So how does AZD get away with keeping things so high level? Thankfully, there's no magic here. Rather than taking an imperative approach, the Azure Developer CLI uses a more declarative paradigm, which allows us to keep commands simple. AZD uses extensible, customizable application templates that include everything you need to get an application up and running on Azure. I like to think about these templates as cloud blueprints or recipes that include sample application code as a proof of concept and reusable infrastructure as code assets that describe the Azure resources needed to host the application. You'll find both an azure.yaml and an infrastructure directory in each AZD-compatible project. The Azure YAML specifies the project metadata, like a path to the project code, language, and Azure hosting service for each component of your application. The infra directory contains all of your infrastructure as code that defines your resources on Azure. You'll also commonly find files for configuring editors like VS Code and Codespaces, sample GitHub action workflows, and more. These templates cover end-to-end scenarios that go far past Hello World. With the CLI, we aren't just supporting you in provisioning infrastructure and deploying code on Azure, but we want to support you in your day-to-day as well. With these templates, the idea is that you can build upon them and make them your own. Find a template at any point in your local development process, initialize the project with the template, swap out the sample app code for your own code, customize the CI/CD pipeline definition, and leverage the infrastructure as code assets without having to get too deep into the weeds. I wanted to take just a second to talk a little bit more about infrastructure as code, or IAC, in case there are folks that aren't super familiar with it. Each AZD-compatible project includes IAC files written in Bicep or Terraform in an infra directory. This directory and the files inside it are integral to how the Azure Developer CLI knows what to provision for you and how to deploy your code on Azure. Infrastructure as code is a way that you can manage and provision your cloud infrastructure and services via code. These files specify the services you want to create, their configurations, and how they interact. Using infrastructure as code, we can ensure that our application's environment is generated in the same way that each time is deployed to the cloud. Infrastructure as code also means that instead of you or your team needing to manage or maintain environment settings individually, you can work off of the same well-documented code that represents your desired environment state, avoiding deployment issues by keeping everything consistent. With the template ecosystem, you don't necessarily have to learn about or write infrastructure as code on day one, as smart defaults are used in the templates. But I did want to highlight these files because they're really the key to how this all works. The best part is that you can always start with the files included in the template and then dig into the cloud specifics slowly when or if your application requirements change. Speaking of templates, there are a ton of templates that you can choose from on our official template gallery that host both Microsoft and community-authored templates. Everything from web apps to microservices to intelligent apps in languages like Python, JavaScript, TypeScript, .NET, and Java. We've got a blueprint for just about every scenario. And if you don't see a template for your particular flavor of application, you can contribute it to the gallery, as everything is open source. Before jumping into VS Code and talking about deploying the application, I wanted to mention that all the code is available at aka.ms/azai/python. You can also pull the code down into your local machine and initialize your application for AZD deployment using this AZD init command. All right, so let's get into it. So I have the app Pamela walked through open in VS Code, and I have AZD and its VS Code extension installed on this machine. Checking out the code base, I've got an azure.yaml, which is really the AZD file. This file tells the Azure Developer CLI about our projects, our architecture and services, and we'll stitch together our application code and infrastructure. What's really neat about the Azure Developer CLI is that it's not just simple to use, it's also extremely extensible. With command and event hooks, we can customize our workflow and deployment. In this case, I've got a pre-command hook defined that will build the services each time I call AZD package, and a post-command hook that will process the Playwright docs after each time I call AZD provision. I've also got an infra directory with IAC files that define all of our Azure resources. For this first deployment, we don't have to worry too much about those files because we can easily make changes to them later on if our requirements change. So I can start by opening the command palette and typing Azure Developer AZD. And here I see a bunch of commands, but right now the most relevant one is AZD up. This is the most magical command that the Azure Developer CLI has to offer, and it's pretty non-magical. I say that because we really want everything the CLI does to be transparent and without hidden side effects so that we can keep things easy to reason about. This command is a convenience gesture which packages the application, provisions infrastructure, and deploys code in one step by wrapping 3 AZD commands: AZD package, AZD provision, and AZD deploy. So let's give it a shot. So I've already authenticated, but because this is my first time running AZD up, I'm asked for a couple pieces of information. First is our environment name. This string is used to differentiate copies of our application on Azure. I'll go ahead and enter ghu-dev, but in a fully fledged app, we might have dev, test, and prod environments, which AZD does support, but for now, I'll keep it simple. Then I'm asked for a subscription and a location, so I'll go ahead and enter those. And that's it. Now the Azure Developer CLI will orchestrate some work on Azure on my behalf, and I could grab a coffee while I wait a couple of minutes for all of the resources to be provisioned and our code to be deployed on Azure. During this process, AZD is packaging the application, setting up all the right cloud-native infrastructure, including creating roles and permissions, and deploying our code, setting you up for success on day one with secure infrastructure that can be easily modified and scaled to meet your requirements. Once this is done, I can see that AZD has packaged the application, printed out a log of everything that was provisioned for us with unique identifiers I can reference in the Azure portal, as well as an endpoint for our app. If I click the endpoint, I can see that I've got a fully functioning version of the application running on Azure infrastructure. To check that this is working, let's ask a question about Playwright and watch it print out a response. I can even see the place in the Playwright docs where it retrieved the information by clicking on the citations. All right, so we've provisioned infrastructure and deployed the application on Azure. Now I'm going to hand it over to Mandy to talk a little bit more about Azure Dev tools that can help us build out and manage our application in VS Code.
So thanks to Savannah and AZD, we've got our application up and running. And that's our goal, is to be able to help you get from idea to production as quickly and easily as possible. We focus on the whole end-to-end developer journey, beginning with the editor or the IDE, where you're writing your code, in Visual Studio Code or Visual Studio, or whatever your favorite editor is. We work on integrations with GitHub Actions and Azure deployment environments to help build your DevOps pipeline. And then helping you connect with all the capabilities of the cloud through things like our Azure SDK. The Azure SDK is a key part of this journey. The Azure SDK provides idiomatic libraries in your favorite language that make it simple to integrate Azure services into your application. And this includes the new Azure OpenAI service. We've recently released updated libraries for Python, JavaScript, Java, and .NET for Azure OpenAI. These libraries include all the capabilities of our Azure SDK libraries, which help you with things like authentication, security, retries, making it easy to bring all of these capabilities into your application. The application template that Savannah deployed is written in Python, and we have this same application template available in JavaScript, Java, and .NET. And all of these templates use the new Azure OpenAI SDK libraries. You can learn more about all of these templates and libraries on the Azure AI Hub. We'd love for you to try these out. The link is here on the screen behind me. And we'd love to hear from you. What would help you get started building these kinds of intelligent applications? Another way that we help you stay focused on your code while connecting to the cloud is through our Azure tools for VS Code. These give you a single view right in your editor to connect with all of your cloud resources and a simplified coding and debugging experience so you can check the status of a resource or change a setting without having to leave your editor. We're going to take a quick look at these and some of the logging and monitoring features as well in VS Code. So we are back in VS Code Our Azure resources are provisioned thanks to Savannah and AZD. Our application is up and running, and I'm in VS Code with this repo open, ready to start working. I also have the Azure tools for VS Code installed. This is a tools pack that has about 8 different extensions that help you use all kinds of different Azure resources. Things like Azure App Service, Azure Functions, including the Azure Developer CLI, which Savannah just showed. You can get all of these in one package together from the Visual Studio Code Marketplace. We're going to take a look at how we use these together to do some of the operations with our Azure resources. The first step is we're going to head over to our Azure tab. And when we land on the Azure tab, we'll see that our resources, we're logged into Azure. We can see all of our resources. And I have choices about how I want to view those resources. By default, you'll see them by the resource type. I can see all of my app service deployments, my functions, my database. I can also choose to group these by resource group, or even by custom tags that I create. Whatever helps me get to the resources that I'm currently working with. Next, we're going to take a look at the local workspace panel. This local workspace panel is about connecting your local dev environment with your cloud deployment. And some of the things that I'll see here is I can see the name of our application, which was specified in the azure.yaml file. And I can also see parts of my application that have been deployed, like the backend service for our chat experience, and the environments that have been created, like the GitHub Universe dev environment, which we see here. If I want to do something like quickly redeploy some of my code to Azure, I can, from this area, quickly choose to deploy to Azure, to refresh my application dependencies, or even repackage my application. But one of my favorite features of this is I can go to my application and choose Show Azure Resource Group. And this will get me right to the resources that exist in Azure that are being used by this application. So this takes us back to our tree view, but this time zoomed in right to the resource group for this application. I can get an even more focused view by using the focus tool, or the little magnifying glass, that will zoom in and take you to just these resources for our intelligent app that we just deployed. So looking at this, I can open up the app service node. I also have one for Azure Storage, where we're storing our documents for the embeddings. And from the app service node, I can see things like the application settings, different databases I'm connected to, different deployment artifacts. And I can get right to the logging and monitoring to help me troubleshoot my app. I can even connect to a live log stream right from within my editor if I'm trying to troubleshoot some kind of issue. Now, we're also using the Azure Storage extension. And because we have all of our documents that are stored in the Azure Storage extension that we're using to embed and help our chat experience know how to answer these Playwright questions, if I go to the extension and drill down all the way to the content node, I can actually see where these documents are getting stored. I can interact with them and see what is in my blob storage that's powering my app. So these are some of the examples of how you can use the Azure tools for VS Code and the Azure Developer CLI together to have everything you need to build and deploy your application to Azure. Now we're ready for some of the next steps where we could take this proof of concept to production by adding things like monitoring, testing, and configuring CI/CD pipelines. I'd like to welcome to the stage Shane Boyer, who's going to take us through some of those steps.
All right. So at this point, we've seen how to get started using the Azure Developer CLI templates to get started, as well as the VS Code tools and the related extensions for developing and maintaining our application locally. But what about day 100? It's not enough to just have an application set up and running in the cloud. We need to make sure that we are infusing the best practices and other things into our workflow. So how do we go about setting up CI/CD, testing, and secure pipelines? So let's jump into VS Code and see how we can use AZD to set up continuous integration and pipelines for this intelligent app. In a terminal, I start by using the AZD pipeline config command to start processing to configure my pipeline. Our directory is not currently set up as a Git repo, so I'm going to be prompted on how I'd like to configure it. I'll select create repo and a new private GitHub repo and hit enter to accept that default repo, and we're off. You'll see here that my federated identity credentials for GitHub are set up, the service principals are created, and I'll set up and get all this connected to my Azure. All right. So next, you'll see all these necessary environment variables securely created for the repo, and the GitHub Actions are created. Once I completed with this, I'm going to be prompted to push these changes and start to configure that pipeline. It takes a second for everything to get committed. Let's jump over to the repo here. All right, we can see where the code and the actions are off and flowing. We'll look at that first one there. All right, and the workflows are all set up for this project, and we can look at that first one. We'll see things are getting built. It's pretty awesome. Now, moving back over into VS Code, we can even use the GitHub Actions extension. We'll hit a refresh to get some things going here. And you can see those same workflows are in progress. As you can see, we got a number of these jobs in progress. And what about the testing here? You can see all these things here. We're setting up a job. Things are getting checked out. Let's collapse this down so we can actually see what's going on here. We're setting up things, running our bicep building for our linting, running prettier. All right, so if we look at this first one here, we'll look at that Python, checking some formats, running some tests there. If I actually click on that Python test and click on the link there, it actually pops me back over and takes us right to the failed job, and we can investigate our failure and we can make those necessary changes and check that in. So using our AZD pipeline config, you can easily set up our CI/CD workflows and even incorporate testing with the tools like Playwright with a single command. Finally, with AZD Monitor, we can see the queries and dashboards that we've been created on our behalf, by the template and in Azure Developer CLI that tracks the usage, performance, and those reliability metrics. That way I know that my app is performing as I expect, and if not, this gives me a solid signal of when I might be able to go in and scale my infrastructure as needed. So today we've shared with you everything that you need to get started building an intelligent apps on Azure. Application templates that you can use to learn about the RAG pattern, tools to help you manage Azure resources, and easy ways to get your GitHub action pipelines up and running. Let me invite my friends back out here. All right, so the sample application that we shared today is available on GitHub in specific versions for Python, Java, JavaScript, and .NET.
So Python's the best. The repos also contain information to help you get started with testing your applications and suggestions on how to move from POC to production.
You can deploy each reference app in one step using AZD app. Because everything is open source, you can also contribute to these samples or contribute your own templates to our official awesome AZD template gallery.
We're really excited to hear about the applications that you will build and to hear your feedback on how we can keep making this journey easier. Thanks for coming, and happy coding.